Hello, can you see the slide? Okay, we are going to talk about. Hello?
Yes, we can see it.
Thanks. So, we want to talk about the critical period for weed control. So, in this case, we want to find out what is the right time to remove weeds in a crop, and also how long we should do it. Uh, in other words, what is the length of the weed free period uh, in a crop in order to maximize yields? So, the questions which we may ask are basically two. Number one, how long should whole weeding be delayed before there is crop yield loss? We know farmers may delay weeding. And to what extent does this affect crop yields? Let's suppose you delay weeding from 1 week, 2 weeks, up to 6 weeks. What can happen to the crop yield? Then, how long? That is the question number two. How long must a crop be free of weeds to prevent yield loss? Should it be 1 week, 2 weeks, maybe 8 weeks? So these are the issues which we wanted to discuss. Now, the current weed control practices under smallholder farming environment may be done at the wrong time. Weeding can be done at the wrong time, or weeding can be done in the wrong places. There may also be too much weeding or not weeding at all. So, if we look at the life cycle of a crop, there are two distinct periods. The first one is the period when weeds do not compete with the crop. So these are the first few days after crop emergence. That is the first part. The second part is the days before the crop reaches maturity. Those are the periods when weeds are not competing with your crop. Then there is this period when weeds compete with the crop, which may stretch from 2 weeks to 6 weeks after crop emergence. Uh, that should be the critical period for weed control. So, the critical period for weed control probably it starts from the time when a delay in weed control results in significant crop yield losses and extends to the time when weed control does not result in significant effects in increasing crop yields. So, probably, roughly, this could be the definition for the critical period for weed control. But we can use graphs to define this period. Here I have got a diagram or two superimposed graphs showing the critical time for weed control. Now I want you to look at the black curve, this line here. This line is representing the weedy period. That is.
Sorry, Doc, the slides are not, they are not moving.
Where are we on the slides?
On the first one.
Okay. We are on this one. What about now? Can you see the slides?
They are now moving.
Oh, they are now moving. Okay.
We are now on the second one.
Okay. Anyway, these are the questions I was trying to put across. When we wanted to define the critical period for weed control, how long should all weeding be delayed before there is a crop yield loss? Can we delay it by 1 week, 2 weeks, 3 weeks, or 6 weeks? And the second question is, can we delay it? The second question is, how long must be a crop be free of weeds to prevent crop yield loss? Is it 1 week, 2 weeks, or up to 8 weeks? So how long must be a crop be free of weeds to prevent crop yield loss? That is the second question. And I was saying that the current situation is that we may have farmers who are weeding at the wrong time, number one. Number two, they may be weeding in wrong places. Number three, there could be too much weeding, or some farmers may fail to weed at all, probably due to labor bottlenecks. Now, during the life cycle of a crop, there can be a period when weeds do not compete with the crop. That is the first scenario. And that first scenario, we can identify two periods. The first few days after crop emergence, the crop is not sensitive to the presence of weeds. In fact, the weeds are not harming the crop. And also, the days just before the crop reaches maturity, also the weeds are not having an impact on crop yield. Then there's a period when weeds actually compete with the crop. This period can stretch from 2 weeks to 6 weeks after crop emergence. And during this period, it is really necessary to remove weeds. Now, this period when weeds should be removed is known as the critical period for weed control. It starts from the time when a delay in weed control results in significant crop yield losses and extends to the time when weed control does not result in significant effects in increasing crop yields. So this is where I was now trying to explain this diagram. Where we have two graphs which can actually define the critical period for weed control. I want you to look at this black curve. It's representing the weed period. So what is happening is that as we delay weeding from 0 up to this point, uh, grain yield is decreasing in this direction. And if we focus on the red curve, which is the weed-free period, as we give the crop uh, weed-free condition, and we increase that condition, we also increase the grain yield. So we now have two superimposed graphs, one represented by a black curve, the weed period, the other one with a red curve, the weed-free period. And here on this y-axis, we have got yield. If there's no interference, it can reach 100%. Now, as a farm manager, you may say probably 10% yield loss may not be much in terms of yield loss. We can mark it on the graph and draw a straight line. Now, when that straight line crosses the weed period curve, that marks the beginning of the critical period for weed control. And when it crosses the red line, that is the weed-free period, that marks the end of the critical period for weed control. And we have put these arrows to indicate this period. So what it means is that weeds should never be there in the field during this period, because this is when the crop is very sensitive to the presence of weeds. If we, let's say, put a herbicide which cover this period, we can maximize our grain yields. Or if we make sure that weeding takes place during this period, we can also maximize the grain yield. And please note that during the early part of the growing season, the crop is not sensitive to the presence of the weeds, and also towards maturity. Weeds are not harming the crop. Another manager may say probably 10% is too much, maybe 5%. So we can have another line which is above this original one. And it may depend. It may depend on the on how the manager looks at the situation. But so this graph could be used as a guide on when to remove the weeds in order to avoid yield reduction due to the presence of weeds. Now, there have been studies on the critical period for weed control. There was a study which was done in soybean by Thomas and Van Lindet in 1980, where they found this, where they came up with this critical period. The red line is the weed-free period. The blue line is the weed period. And please notice that the critical period for weed control may start from 2 weeks and it can go up to 6 weeks. This is what they found in a soybean crop after 4 seasons of study. These then are the treatments which we can use if we want to model the critical period for weed control in any crop. So you need the two sets of treatments, what we call the weed period, which can vary from 0, 2, 4, 6, and 8 weeks. Please notice on the weed period, 0 means no weeds. Then the weed-free period, which can also be varied from 0 to 6, 2, 4, and 8 weeks. And please note that 0 here on the weed-free period means presence of weeds. So these two sets of treatments can give us this kind of a graph in any crop. And we can estimate the critical time for weeding in any crop. Now, data on critical period for weed control in Zimbabwe is suggested that in most cases, the critical period for weed control starts from 2 weeks after crop emergence and extends to 6 or 8 weeks after crop emergence. So this is looking at various crops which we can grow in this country. The critical period for weed control can stretch from 2 weeks, probably up to 6 or 8 weeks. Now, for example, this period stretched from 2 to 6 weeks in soybeans, as was reported by Thomas and Van Lindet in 1980. However, in winter cereals, it has hardly been determined because I think most of the weeds in winter cereals are killed by frost. This is soybean infested with weeds. Now we want to look at the factors which can affect weed competition or which can affect this period. We want to look at what factors can affect this period. We are saying in Zimbabwe, it stretches from 2 weeks up to 6 or 8 weeks. So we want to find what can actually affect its length. Number one, period of weed seedling emergence relative to crop emergence. If weeds germinate before crop emergence, it means the weeds will be highly competitive, like what happens in conservation agriculture. Now, we are saying that farmers should come in at 2 weeks after crop emergence. In this case, it may be too late. Farmers may as well come in and remove weeds before even the crop emerges. Otherwise, there will be serious loss of weeds. So that model, this model here, may not apply. Let's say weeds emerge before crop emergence. We are saying the critical period start from here. Maybe it shifts up to this point. Now, weeds that emerge with the crop are also highly competitive. So maybe farmers should come in earlier than 2 weeks. Weeds that germinate after, or weeds that germinate with the crop may be coming in at 2 weeks is okay. Weeds that germinate after crop emergence are less competitive. So after crop emergence, well, uh, weeding may not be very critical. The other factor is weed density. Remember, there is a minimum weed density which affects crop yields. We call this the weed control threshold. And in fact, increasing weed density tends to decrease crop yield. So if the density is very high, farmers need to come in and remove weeds, maybe starting from 2 weeks. But if the weed density is very low, maybe it may not be necessary to even weed. Another factor is crop density, number 3. Increasing crop population can decrease weed population. So sometimes one can easily delay weeding if the density of the crop is probably optimum. If it is less dense, maybe the farmers need to come in early. Weed species present, we now know that weeds have different competitive abilities. So, for example, Rapoco versus Mexican clover, Rapoco is said to be more competitive. Pigweed versus blackjack, pigweed may be more competitive. So, depending on the weeds which are present, maybe the farmer need, in the presence of Rapoco grass or pigweed, maybe the farmers need to come in around 2 weeks. With the blackjack probably or Mexican clover, maybe they may delay and still get their yields. The other is the crop species and the varietal effects. Now, crop genotypes have different tolerances to weed competition. For example, we have got barley, rye, wheat, and oat, which may tolerate wheat competition in that order. For example, rye tolerates weeds better than barley. Wheat tolerates weeds better than rye, and oats tolerate weeds better than wheat. So oats could be the best crop to tolerate weeds. So crops which may tolerate weeds may suppress, tolerate weed competition may actually suppress weeds. However, we may need to do some studies to find out which crops actually suppress weeds. So if you have such a crop, delaying weeding may not be a serious issue. You can even come at 4 weeks or 6 weeks without decreasing the yield But of course, we need to know those crops. Number 6, soil and climate factors. Now, soil fertility can alter the direction of wheat competition. For example, low nitrogen, phosphorus, and potassium can trigger serious competition for nutrients. Soil moisture, rainfall, drought conditions, or a drought season may require farmers to remove weeds at 2 weeks after crop emergence or even earlier. But in a wet season, they could actually relax and remove these weeds by 8 weeks after crop emergence. Anyway, that is the boundary, or that is where the critical period for weed control may end, according to Thomas, 1972. Soil pH may also influence the time when weeds have to be removed, especially low pH. There could be serious weed competition in maize, as was reported by Makanganisa et al., 1999. This means that weeds have to be removed much earlier under low soil pH. Now, cropping practices can also influence the time of weed removal. For example, the time of planting. Now, if you plant early, is what is recommended, and which is quite, farmers should actually plant early. But the downside is that this planting may coincide with the first flush of weeds, which is highly competitive. And the second flush of weeds, in contrast, is less competitive, but can lead to delayed planting, and there could be penalties, of course, in grain yield loss. It's a question of if you come in early, make sure you have to remove the weeds. Otherwise, you may lose uh, yield. So with the first flush of weeds, maybe we need to come in and weed around 2 weeks. But with the second flush of weeds, maybe we can delay weeding and get away with it. Now, in flare areas like Chiota and Mashingo, where maize can be planted in August and September, what happens is that the seed of the crop can be surrounded by moisture and it can germinate, whereas the weed seeds may be in the dry zone during August to September and they may fail to emerge. So the crop can emerge in a weed-free environment. Now, in that case, probably you can actually delay weeding even up to 8 weeks, depending whether some rains have fallen between August and September. So flare areas can influence time of weeding. Crop density and rectangularity. Now, it is possible to eliminate weeding altogether by manipulating crop density and rectangularity. For example, there's what we call square planting, which can actually reduce weed competition. Probably you may need to read this paper, effect of weed density, effect of density and sowing pattern on weed suppression and grain yield in 3 varieties of maize under high weed pressure. In this paper, the scientists are demonstrating that with some varieties planted at a certain density, they can actually tolerate the presence of weeds. Here I've got 3 varieties, and the weeds were monitored 1 month after sowing and at harvest. What I wanted to quickly point out is that using this variety, Novilero, a maize variety, when it was planted in grids, you could see that weed biomass could be reduced as crop density was increased. This was, quite dramatic in this variety. Even at harvest, the weeds showed a decreasing trend. But of course, with these other varieties, they are not as dramatic as this variety. So we've got this variety which is not that responsive. So you can choose a variety and a density which can actually decrease weeds, and you may not have to weed. So I just want to summarize this critical period for weed control. We said that it can stretch from 2 to 8 weeks after crop emergence, but it is variable because of certain factors. Now, these then are the factors which affect crop, the critical period for weed control. Number 1, period of weed seedling emergence. Number 2, weed density. 3, crop density. 4, weed species, which have got different competitive abilities. Then 5, crop species and varietal effects. 6, soil and climate factors. 7, soil pH. And 8, cropping practices, such as time of planting and crop density and rectangularity. Okay, this is the end of this lecture. Let me let me uh, let me stop recording.